I do a countdown. It's weird. Almost like a movie.
Recording. Come on.
All right, so I am gonna give you a quick intro to Modelina and how it's structured, how it works, how it can be customized. Um, we are gonna try to create a new generator for ghost structs after this introduction. But yeah, in Modelina we have three different kind of generators at the moment. We have for TypeScript, JavaScript, and Java. Now each generator can produce different kind of model types. For TypeScript, this can be, for example, interface, class, um, and this is based on what your use case is. So it is to allow different kinds of customization or tuning to your use case. Now, at the moment, the library supports two different kinds of inputs. It supports an async API document, which then generates all the models for the entire document, all of the messages, message payloads, to ensure that you have all the needed models for that document. It also supports JSON schema draft 7 as the only version at the moment, because that's what we are using in 2.0 in Async API for the message payload. In general, whenever you have your document and you generate your models, it will return between 0 and as many models as the generator see fit. This means that it controls whether to split out models. This means that if you have nested object models or object JSON schema definitions, it will split out these models into separate models and then reference them. It allows for using any kind of or there's no restrictions to which keywords are supported from JSON schema. Everything should be allowed. So it basically just interprets the document. It then generates or gives you the model as a string, because you don't necessarily want to just have the file. You might also just want the output as is. And this is especially useful if you want to generate everything in a single file, or if you want to split them out yourself into separate files, depending on your use case. We have an issue later for adding a CLI to allow this to be generated to files directly, but it's not a priority at the moment. The generators have extensive customization. This means that you can customize the process in any way that you want. And it does this through something called presets. This means that you can change the behavior of the specific model generation for both class, interface, enums, basically whatever your use case requires. Let me find a place where we actually do it. For example, you could add or prepend anything to an existing rendered content. This means that you could, for example, add this JSON property annotation before both getters methods, setter methods, or the property rendering itself. But yeah, that's as soon as we allow for this extensive customization, it also makes the implementation a little bit harder because we have to call certain functions or presets at certain what's it called? Certain times during the rendering process. Whenever this is to go a little bit deeper into the library, whenever we reach the generator, the input has already been processed down to something we call the common model. Now, the common model uses all the same properties from JSON schema draft 7, or not all, but some of the properties. And it only adds very few properties on its own. It only adds something called extend and original schema. Original schema is to it should be original input, but this is the schema version of this model. The extend is for extending other models, if you allow that. These are the properties from JSON schema draft 7 that the common model uses or shares. The difference is that as soon as you are in common model or in an instance of common model, this will no longer be validation rules. This will be pure definitions. This means that whenever you have certain properties, for example, in this case, whenever we are on the JSON schema or it defines it as a JSON schema, you basically define it to match an object which can have a property or property which should match a string. It doesn't say that the property should be defined as a string, but it does whenever you whenever it gets to the common model or are interpreted to the common model. This means that it's way easier from the generation point of view because you can take it as is. You don't have to interpret what it states. I think that's more or less that as a code canvas fail. Do you have any questions, Sergio?
I would really like to see this in action, right? Like, I would like to see how a generator works behind this. Will you mind sharing, I don't know, taking one generator as example so we can see how it works a bit? Just a brief introduction. I think it would be cool.
Of course. Let's see if I can find it myself. So let's take basically from the README file that example, right? TypeScript generator. So oops. So all the generators inherits from this abstract generator. This means that it's for TypeScript, Java, and Go. It handles all of the processing using the different input processors, which means that whenever you call generate, it pre-processes the input and basically converts it to a common model or common models. And the common models are wrapped in this common input model. It basically just contains a map of models with their ID and then the common model. And then it provides you with the original input data, whatever that input was. If you provided an AsyncAPI document, it would provide you with an AsyncAPI document or JSON schema, whatever it used to generate the models. Whenever the input has been processed, do you want to go into how it processes the input, or do you just want to abstract it away there?
I think we can just go on top of that, so you don't have to go into that details.
Sure. So whenever we have processed the input and have our common model, common input model, we then generate the models. This is it does this by rendering each of the separate models. So this means that it iterates over each of the common models and then renders it using whatever rendering method has been implemented. When you call the TypeScript generator, it then calls this. So at this point right here, the rendered output is based on whether it's a TypeScript generator, Java generator, JavaScript generator. Because it's an abstract method that is then implemented here. Now, what the generator does, or in this case, the TypeScript generator, is that it assesses whether or not, like which kind of model is it? Is it supposed to generate an object, an enum, or however does it need to render this? In most cases, it will probably just render as a simple object or a class or an interface, depending on the model type. From default, this is class. When we render the model type, we either default to render class or we render interface, right? And if we just follow along with the render class, we then starts to notice some presets functionality. So this is where it calls the different presets.
What is a preset here?
So a preset here could be something that you have provided in the whenever you created the TypeScript generator. An example of this could be here, for example. Whenever you initialize the TypeScript generator, you define some different presets. In our case, it looks for class. It does here, get presets class. Then it finds all the presets that you've defined as class. And then it renders or initialize a class render based on those presets. And then it runs this run self preset. For the class generator, this is abstract renderer run self preset. So this run self preset runs the preset that's called self. This means that it calls this one right here. Now the self is basically the entire rendering. It defines how you want to render the model. So this means that if I override this right here and just return stuff and does absolutely nothing else, this means that the output here would just be stuff because it does nothing.
Makes sense. Got
it. By default, we have these different kinds of renderers. I think it's defined here on, yeah. So we have this default class preset. This is what this is the presets that's called by default. We don't hard code anything from default. We use presets in the backend as well. This means that you basically just override an already existing preset whenever you customize something. Maybe I should use the class instead. But so this self is now called. This is the absolute start of the rendering process. And here it calls default self. Default self then calls a lot of different stuff. This default self function renders the properties, the constructor, render accessors, or any additional content presets. This means that it basically just sums up all of the different strings that has been rendered using presets. So when you want to render properties, this one is called here, one property preset, which then calls the preset, whatever it is, and defaults back to this one here, which is defined as the default, right? This is also an important note that whenever you override something, like here, when you override the default behavior, I think you override it, it might actually generate it from whatever. When you override it here, it's important to note that you override the default behavior, and you have to call certain things on your own for it to do what you want it to.
Would it make sense to, if I go here and I want to overwrite something, would it make sense to start by just copy and pasting the default and then just modifying it?
It could be, yeah. It depends on how much customization you want, right? Because if you just want to prepend or append something after it generated the properties, it would be way easier to just do this, right? And then say, I want to append something to the existing generated content and then add this means that it will append to this, right? So it depends on your use case, basically. And if you want to have very specific things generated, it would probably make sense to do this. Maybe it does. It depends on your use case. Yeah.
Gotcha. Thanks.
No worries. But yes, for the presets, we don't have our general mindset at the moment is that we want to have as few presets as possible. This means that we do not want to create that many more presets than what we have now. We don't want to add something like a pin property or a pin to property or a prepend, or we don't want to not overflow, but to add too many where it gets confusing real quick. So whenever we want to keep it as minimal as possible, especially since you can use this to do basically any customization you want. For the presets, we do have the documentation here explaining exactly what properties are available at the call. So you know which arguments are available. And this is also specific for like this can change based on the language. So each language generator can customize this however they like. But generally it's this, like, as you can see for JavaScript, it's this. For Java, it's this. It's basically the same. There isn't any use cases at the moment where this needs to be different at the moment.
Yeah, I can see as they are sharing the same presets or kind of presets.
Yeah.
But each of them, like you could create another renderer that doesn't follow this, right? It's open to. Cool.
Yes. All of the presets are part of this preset model, which means that we are using quite extensively generics, which is like it complicates, not complicates, but it makes it less easy to understand right from the bat, especially since then all of a sudden when you have two different generics and then extends update and all kinds of weird shit. But generally these are never changed, so I think it is what it is. So that was presets. And this is also something in Go that we have to discuss. How many different types of structs are there? How can it be structured? Or maybe just focus on a single struct at the moment or render, so we don't overcomplicate it and then add more later. Oh yeah, and we also have we are saving different kind of presets. For example, for Jackson presets where you add annotations to your accesses.
Okay, I see. So you provide the default, but then you also, it's up to the renderer to provide, if it's so common, right? Like a framework or a ORM or whatever. So then you provide. It is up to the, I guess, to the developer, or up to if people ask for it. If they don't have to always do the same kind of presets by their own. Cool.
Exactly. So we still haven't decided how we want to control this, because too many presets is also going to be confusing. So we have no rules at the moment to which presets are or should be added and which should not. So at the moment there's just free, what's it called? Not free work, but you can do whatever you want at the moment. But yeah, I think that is the basics of it. So that's pretty straightforward, right? To add Go, easy.
I think it's okay. It's pretty. I mean, it was a good tour over Modelina, and it's something to use to start digging into. So
Yeah,
that was cool. So I appreciate your time here.
no worries.
Gonna stop the
Should we
recording.
split up? Should we split up the recording into the
Yep,
introduction and then the yeah?
I'm gonna stop it here.
Uh-huh.